chat. There we go. Hey, look at that design. That's awesome. Congratulations.
Pamela's having fun tweaking that in every week or so.
Mm-hmm. It was a bold new design. Are we? Oh.
No, let's go.
Yeah, that's the tragic reality of when you volunteer to do something, is then you're on the hook to do that thing and every version of that thing and all the iterations and constant support from now and forever.
That's the joy of volunteerism, isn't it?
Exactly. You can't just do a favor. You're married to it for life.
No good deed goes unpunished.
Yeah, exactly. Like when I helped my father, I built a web server for my father so that he can run his blog, and every few months I'm like, Fraser, my blog is down. I'm like, oh.
Well, yeah, then you're the only one that knows how to.
And then I'm the only one who knows how, exactly.
Yeah,
exactly. And so then I'm there providing technical support in perpetuity. So yeah. Buddy, you're worth it, Dad. I love you.
I mean, one of my friends in high school taught me computer science. I still pester him with questions now, 30 years later.
Yeah. I will reward your favor with more work.
More favors.
Yeah, exactly. Oh, I'm sorry. Was it 2 a.m? I was just wondering if N is not equal to NP. No reason. Yeah. That was a computer science joke. Beth got it.
Ruby, Python, discuss.
Oh, I got the wrong mic. Why don't you guys warn me that I have the wrong mic?
Oh,
I
thought you have the wrong mic.
Thank you. You have the wrong mic?
You sound like you're down a drainage pipe or something.
Yeah. This rendezvous software, even though I choose the right mic, it unchooses the right mic and goes with the wrong mic every time.
Every single time. And if I do it from one of my browsers, it goes with the wrong camera every time too.
Every time.
No, yeah. I'm on the right mic.
Yeah, no, you all sound great, but yeah, that's the. But thanks, John, for catching that. And it'll happen I try to catch it as many times as I can, but still, it never does what it's supposed to do.
See, this is why some of us only have one camera and one microphone.
Oh, amateur! Are you kidding?
I know, right?
Yeah.
I mean, I have 3 cameras just from the monitor, and the laptop, and then the one I bought alone. Like,
yeah.
During the virtual star party, it was handy though, because then I could switch back and forth from the telescope to my view.
Yeah, for sure. So I've got, let's see, 1, 2, 3, 4, 5, 6, 7, 8 cameras, but really I only have 3. And then microphones, I have 1, 2, 3, 4, 5 microphones.
Good Lord.
Yeah. And you heard one of them.
See, I just thought I was doing well to have a hands-free set that I could use with better sound quality than the built-in microphone.
Well, no. I mean, it's like
I'm the new guy. 4
garbage microphones that are like as part of, a light or a water bottle, right? Yeah. Like they're I don't know why they included it. Hey, we can include a microphone. Let's do it. And
why would you have a microphone in a water bottle? I'm just curious here.
Why would you have all these garbage microphones on a computer? I don't know why. But yeah, so the point being, like, sometimes they're so busy wondering if they could.
They didn't stop to think if they should. Yeah,
exactly.
Yeah, because you're right. Now that I think about it, I think the monitor and the laptop do have built-in mics as well. So yeah, two garbage mics there, 1 garbage mic on the camera.
Yep.
This good mic. Then there's also the headset that I use for when I'm not being all super professional.
Yeah. So deliver a good quality microphone, or don't have one. So, but also the distance to the microphone is an issue. Yeah. If you're far away from your microphone, it doesn't work so great. Anyway. I'm bored.
Or if you turn it around backward.
I'm bored of this idle chit chat that I have led us down some kind of rabbit hole. So I think it's time to start the show. All right. Hello and welcome to the Weekly Space Hangout for Wednesday, December 8th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about tests finding a lightweight Mars-sized world, tracking a near-Earth asteroid, the end of ISS, catch a visible comet, space tourism, good or bad? And laser telecom, what exists? What are we working on? So joining me this week, we've got a whole new layout, but now we've got Beth Johnson. Beth.
Hello, Fraser.
Welcome back. We've got Dave Dickinson. Hey, Dave.
Hey, busy space news month, and that's a good thing.
Yeah, with the big news on the 22nd.
Well, we've got ISSPs launching tonight, too. We've got another space telescope going up. So.
Yeah, there's a lot of good stuff. You're right. We don't have time for the holidays, I think. We just cancel it this year. All right, we got Nick Castle. Hey, Nick.
Hey, how's it going?
Very well. Now, before we get into this week's special guest, I want to give a huge shout out, thumbs up to our good friends at the Weekly Space Hangout crew. They're our friends, our fans, our executive producers, and you can join this amazing community. Go to wshcrew.space and they will welcome you and give you lots of cool space information and access to our executive producer, club, so that you can invite more guests to the show. And speaking of guests, we've got Dr. Saverio Cambioni. Saverio, welcome to the Weekly Space Hangout.
Hi, thank you for having me. This is great.
So the question that we always ask, who are you and what do you do?
Yeah, thank you. I am a planetary scientist interested in the formation and evolution of asteroids and terrestrial planets. Actually, I'm very excited that you're going to talk about the Mars-sized planets as well. That's pretty cool.
Well, so I think today, based on your background, today is going to be a moment of catharsis for a lot of the fans of the show, a lot of the members of the CosmoQuest community who slaved away for months identifying all of the rocks on asteroid Bennu as part of the OSIRIS-REx mission. So why does Bennu have so many rocks?
Yeah, that's a great question that gave us a lot of of thinking, and the solution that we come up with was actually a sort of surprise, and we figured out that it's probably the highly porous rock, like the high porosity of the rocks on Bennu, that is responsible for the lack of basically the fine material that OSIRIS-REx was designed to sample. So the rocks, the high porosity of the rocks prevent the rocks to fragment efficiently, and these are it's why there are rocks everywhere.
So can you give me an example of what a hyperporous rock is?
Yeah, I can give you a number. We found that most of the rocks on Bennu are in the order of 50-60% porosity. So it means that your volume of voids, it's more than half of the volume of the rock. So it's basically like the equivalent of a sponge,
right, like a sponge. Yeah. So what? I mean, I'm kind of imagining when volcanoes throw out material, some of the rocks will actually float. I don't know.
We focused is how you evolve the surface starting from this type of high porosity rocks. And the way I actually see the slides here, there are two main reasons. The first one is impacts, similar of the debris that or the meteoroids that can manage the space station, for instance, there is a similar principle. You have this striking the surface, and depending on the porosity of the rock, you break differently on the surface. High porosity rocks, they compact because you have these pores that basically are crunched by the impact, and the rock doesn't break. And then you have it's another process, which is the heating and cooling down of the rocks, and that is also able to break the rock because it propagates fractures in the rock.
Right.
And that the more denser rock, the denser rocks, they break more fast for this process as well.
So if it was a denser rock, then it wouldn't be broken up so easily. I'm kind of imagining breaking open an aero bar or something. But anyway, if it was a denser rock, it would it wouldn't shatter into all these little pieces that are then crumbled up across the surface of Bennu.
Actually, if you are if it's a denser rock, we find, and this is supported by laboratory experiments as well, that if it's a denser rock, this rock fragments more easily.
Really?
And there is, yeah, okay. That actually there was a surprise for me as well, because I'm actually an engineer, as a background, and I study planetary science. It's like for 5 years now, and but I'm not an expert of impacts. And some colleague of mine, co-authors on the paper, they show me this literature showing that because you have pores in the rocks, the energy of the impact goes first in crunching the pores, and then to break the rock. While instead, if you have a denser rock that doesn't have a lot of pores, all the energy of the impact go to break the rock. And so to make these fragments that then in a cascade will form the fine material that we were expected to find on Bennu.
So we saw a similar kind of asteroid with Ryugu. Do we think that it's the same situation happening there?
Yes. Actually, the results of the Hayabusa 2 mission, they also analyzed the temperature of the surface, and they come up with independently of us of a value of rock porosity, which is pretty similar to Bennu. And the spacecraft found that the surface is rocky, as well. So that line up with the theory that we proposed.
And seeing two objects like this out of all of the asteroids that have ever been visited close, are we now getting a sense of how common these rubble piles are?
Yeah, that's a good question. The passage between being a rubble pile and not a rubble pile as a function of the size of the asteroid is still an open question of research. We know that the smallest asteroids are collisionally evolved, meaning that they are accumulated fragments of what was once a larger asteroid. But I think our work goes in the direction of showing what drives the diversity of asteroids. You may remember Itokawa, for instance, that was visited by Hayabusa mission in 2005. That showed some grain material on the surface, and its rocks indeed are denser. So that's another point of evidence that we used to put together this model.
It's interesting that, Itokawa, I'm trying to think if it was bigger than Ryugu and Bennu, but clearly looked like a solid object as opposed to this, I don't know, diamond-shaped rubble pile the way the other two were. And do you have a sense of why these asteroids end up with this shape? Why they get this very characteristic diamond shape?
Yeah, the diamond shape is due to it's still an open question too, but the current understanding is that the thermal forces, what is called in jargon the Yarkovsky effect, is basically a recoil effect. Due to the fact that the surface doesn't basically give back all the heat instantaneously, and also it's basically the rotation that this gives. It can move rocks around, and the configuration, the equilibrium configuration shape, it's that of a diamond. But I don't know why Itokawa is not a diamond. Yeah, that's a good question.
Yeah. Well, sorry, Pamela is saying it's a D20 in the chat. I disagree. I agree with Nick that it's a D10. Clearly, not a D20. D20 is like a dodecahedron, but a D10 has that weird diamond shape to it. Or
I would have a D12.
A D12, a D8. No, a
D12
D12
wonderful
is
horizontal symmetry plane as opposed to the vertical spin axis.
Yeah.
No, I think you're right. I think a D8 is probably more what we're thinking.
Yeah, D8. Yeah. So there we go. There's these things in nature. But a lot of your work as well is in modeling and thinking about how these collisions happen. So what kind of collisions has the solar system been getting up to create the kinds of objects that we see? Is there like a newer sense of how violent the solar system has been in the past?
Yeah, that's a great question. There is like the previous understanding was a sort of like very organized and orderly growth of the solar system, in which like the bigger bodies were sweeping like the smaller one and basically getting bigger and bigger until you get Earth and Venus and the other planets. But that doesn't explain that very well, like why you have the Mercury and why you have also asteroids down to meta-rich asteroids like Psyche, for instance. So collisions are not such an orderly process. A lot of the collisions end up with a lot of debris being produced, and this process of accretion is not that organized or linear. Actually, could have been that there have been setbacks in which accretion was not actually the most common of the outcomes, and then you have instead that like in a period that is more common. So we are actually studying that. It's a bit challenging because it's a lot of parameters and models, and we are actually using indeed machine learning to try to help to explore the.
Yeah, but I think that that idea, that traditional model where you had fairly large objects that were orbiting around in those regions, Earth, Mars, Venus, Jupiter, etc., each one collecting material, but it really starts to look like there was a lot more interaction, the kinds of things that formed the moon when a Mars-sized object crashed into the moon. Do we think that there was just a lot more of that kind of destruction?
Yes, like that. That's it's what I think like the direction of research is bringing us. There are, although like there are alternative models, for instance, the possibility that what was the proto-Earth, like so the embryo of Earth and the other planet just emerged as already big planets, like almost formed final planets. And then maybe you have a couple of collisions that finish the job, so to speak. One forms the moon, for instance, and another may have formed Mercury. There are challenges to these models, but the role of collisions in the final assembly of the planets and the evolution of the solar system and also exoplanetary system is progressively becoming more clear. That has been a fundamental process.
Well, we see, I mean, I guess, we see there's two general proposals for how we got shifts in the objects in the solar system. One is these giant collisions. The other one is through migration. Which one at this point do you think is caused more of the modern solar system that we see today? I'm thinking about Venus with its backwards rotation. I'm thinking about Uranus flipped over on its side, as well as the orbital tilts and so on for even some of the other planets. Do you think it's more about migration or more about collision?
I think the two processes, if they occur at different times. Like migration, it's a process that occur early on, and at least the models that I'm not an expert of migration, but I know that it's earlier than this process. The collisions that I study and also at the level also of collisions that created the asteroids like Bennu and Ryugu, these are occurring later on, and the reason why is because you have to wait that the gas dissipates, like the nebular gas dissipates, so that the orbits of the planets become basically planet crossing, because you have to have collisions. That doesn't mean that the collisions didn't happen before. They were happening also when the planets were embedded in the gas. But I don't see the two models at the moment mutually exclusive. They may be separated in time.
Really interesting. it's such an interesting unfolding science at this point. I mean, we see new papers coming out, new stories coming out almost every month or so with major insights into a lot of these discoveries. So it's quite an exciting time to figure out the early solar system. Now, Saverio, you're going to stick around with us. We're going to talk about a bunch of other space news today, but I want to give people a chance to find out more about your work and find out more about what you're working on. So I guess, what project are you working on right now, and where can people find out more?
So at the moment, I'm a postdoctoral fellow at MIT, and I'm working on the formation of metal-rich objects and bodies. That's actually why I'm excited that, like you're also talking about Mars, and ranging from a large asteroids like 16 Psyche to actually extrasolar planets. And you can find more about my work on my website. If you type my name and surname, it's like a link to that. I also have a Twitter channel, although I don't use it that often, but it's
probably best.
Probably it's best indeed. Like it's AstroSave1, but yeah, you can just send me an email on the address, like on the MIT website. I would be happy to.
Fantastic. Well, thank you so much for taking the time to talk to us today. And I think some of the stuff we're going to be talking about will be in your wheelhouse. So don't be surprised if I come back and hit you with a couple more questions. But thank you.
Thank you. All
right, let's move on to the space news portion of this week's episode. Beth, once again, yes, you are next in line on my screen, and that's how I roll. So let's. Of the two stories that you proposed, let's talk about the lightweight Mars-sized world first.
Okay, so scientists primarily working out of MIT. So I'm sure Saverio knows some of these guys. Have found, using test mission data, a Mars-sized planet called GJ367b. And it is orbiting a red dwarf star in about 8 hours. So it has a super fast, super close orbit. And then because it's so small and it's so close, they actually were able to figure out how big it is and what the mass is. So it's a rocky world, but it's similar in composition to Mercury. So they think that about 86% of it is made up of an iron nickel core.
That's amazing. It's 8 hours. That's mental. It's
8 hours.
Yeah, I saw that story come through, and I said, and I remember like 2 weeks ago, we covered one that did it in 16 hours. And that was the fastest planet ever seen. And this one just destroyed that record. 8 hours is crazy. Of course. Really fast. Yeah, of course, it's going around a red dwarf, so they're a lot smaller. So there's more room to work with, but still, that's crazy. How hard do you think it was for them to find a Mars-sized world? That's the smallest world found with tests so far, isn't it?
I think so. I don't recall anything. I don't recall anything smaller being found yet. They actually found it in 2019 in TESS's data. And then they went to the HARPS instrument, which is on the ESO telescope in Chile. Mm-hmm. So that's the High Accuracy Radial Velocity Planet Searcher. And they confirmed it. And that's what they used to calculate all of the characteristics, is they actually just had a chance to sort of observe. 8 hours, you can get a few passes in a few days.
What's the physical separation between the two, Beth? Do you know?
It doesn't say. So they didn't. Close. It's got to be really close. One of the things that they said is that it's definitely not habitable. it gets about 500 times the radiation that the Earth gets from the sun, and the daytime temperatures are upwards of 1,500 degrees Celsius. Wow. So not a habitable world. But the really interesting thing here, aside from the composition, because it's on a red dwarf, they suspect that there are other planets around this star, and that some of those may actually be more habitable in nature. So they're looking for more of them.
I'm seeing if I could find the information, But the fact that, there's so many parts of this that are so amazing. Like, this idea that they followed up the actual observations using the transit method with the radial velocity method on a planet the size of Mars is a sort of phenomenal piece of astronomy to be able to do both of those. And that's what you need to get to get both the size and the mass, is you need both the transit and the radial velocity. You can't get one without the other. Just incredible science. Do you think we're going to find more of these? Is this the limits of TESS?
I don't know. I hope not. But finding Mars-sized world is really good, because that gives me hope that we're going to start finding some more Earth-sized worlds.
Yes, yeah. Although finding Earth-sized worlds around red dwarf stars is less exciting than finding an Earth-sized world around a sun-like star, but that's
exactly
tricky business. But still,
yeah,
absolutely incredible piece of news. Amazing. Thanks, Beth. Dave.
Yes.
Let's talk about the comet first, and then we'll come back
Okay.
around and talk about the ISS.
Yes, we have a very good binocular comet. Possibly it might be naked eye, but the thing is, you got to see it in the next few days, because it's going to start moving over to the evening sky after about mid-December, and the evening apparition is not going to be as good. Right now, it's up. You've got about an hour to hour and a half prior to sunrise is the best time to go out right now and see this in the east. I finally got a look at it last week. The weather here on the East Coast, as usual, has always been cloudy.
Yep.
I may have one more chance looking ahead at the weather forecast, so I'm going to try to get the unistellar scope up on the roof tomorrow night or tomorrow morning, if I can get up in time and get a look at it. It's about 5th magnitude right now. Like I said, for a comet, that's right on the edge of naked eye, but we're getting a lot of good photographs of it. This is, by the way, it's Comet C 2021 A1 Leonard. It was the very first comet. That's why it has the A1 designation, that was discovered earlier this year. And we knew automatically, looking at its orbit, that it was going to be an interesting comet. It passes by in a few days. It's going to be doing it's like, I think, 4 million miles from the Earth, I believe. It's like 0.2 AU. And so that's actually a shot right there that I took with the unistellar scope.
Oh, that's your picture. Nice.
Yeah, that's about 90 seconds with the unistellar scope. You just put it on it and it just automatically stacks images. And keep in mind, this is from an urban environment. I have a very light polluted. I'm up on the parking garage roof in downtown Norfolk imaging it here. It amazes me you can catch things with it at all.
Did it have it as a designation in its computer, or did you have to put in the right ascension and declination to find it?
It did. For this one, it did. Yes, sometimes I do have to do that for other fainter comets. I have to manually type in. You just have to look it up beforehand and type in and tell it to look at a certain point in the sky. But for this one, they do, in the unistellar database, they do have A1 Leonard. So all I got to do is turn the scope on, Wi-Fi it up to my smartphone, start typing LEON, and then it comes up in the database.
Oh, nice. Okay.
And then you just and it just does its thing. It's all GPS controlled, and I'm just sitting there waiting for it to stack images, and it's kind of nifty.
Is there any chance of it brightening more significantly?
It could. So David Levy once said that comets are like cats. They have tails and they do whatever they want. So it's possible it could brighten ahead of expectations. It could fragment. It could fade away and fizzle like Comet Ison did Thanksgiving year 7-8 years ago, that we were all excited for the comet of the century. I just started writing for you when Comet Ison.
I know. We were all over the Ison beat. That was it. That was going to be the one, and then it went behind the sun and it didn't come out the other side.
It fizzled at perihelion. Yeah, it's gonna. This one Leonard's gonna come around in the evening, but the problem is it's gonna be way further south. There's a much better image that was nice. Michael Yeager. Late November, I believe, shot this from. He's a very accomplished astrophotographer. I always hit him up for comet images because I know he's always out there shooting stuff. But it's I'm seeing some really. It passed by globular cluster Messier 3 a few days ago, and there was a lot of good images came out of that. It almost passed right in front of it, so that was a very photogenic pass. But the window is closing for the morning apparition here over this.
I always lament that we've got all of this technology, all of this gear, all of this expertise to do incredible astrophotography, and there has not been a good comet. And
yeah, it's really ironic, right? Hale-Bopp and Hyakutake in the 90s came by right in quick succession, right on the cusp of film changing over to digital astrophotography. There were a few people tinkering with digital then, but it was predominantly film astrophotography. And it's weird when you look for images online of Comet Hale-Bopp, there's not a lot of spectacular images. There's some good ones, but everybody was shooting with film, and not all of that got transcribed up to the internet. So we haven't had a good comet since then. So
and so I wonder what will happen when
Comet Neowise last summer, and that was I think made it to first magnitude. You could see it naked eye, but
I was able to see it with my eyes from my sort of fairly low light polluted city, and it looked great in binoculars, and I was able to take a bunch of pictures of it and so on. But still, I mean,
you saw all the pictures people were taking of that. Once they get to be about second or third magnitude, you can start positioning the comets bright enough to position it with foreground objects like buildings or landscape or things like that. Then you can get those really photogenic kind of shots. Yeah,
but we're still it's like all of this technology and capability skill waiting for the next great comet, and we still haven't gotten it. And
the wild thing about the comet is it's on an 80,000-year orbit inbound, but it's getting ejected from the solar system afterwards, so it's not coming back.
So we're sending out an interstellar object.
We are. Oh yeah, this happens occasionally. It makes, like I said, it's a 0.2 AU pass by Earth. It makes a closer pass by Venus, so it's having its orbit kind of modified a bit.
So cool. Awesome. All right. Well, give us an update, hopefully, if it gets better. Nick, let's talk about your second story first, as you chose, and we can save the more controversial topic later on.
Yeah. So NASA's ready to launch a new laser telecommunication satellite. And they're trying to work through some of how to make this a more realistic technology. One of the reasons why they're working on this is because the information density you can send over laser is 10 to 100 times higher than what you can do through radio. Now, we do use laser communication between satellites right now, but one of the ones that we haven't quite sorted out how to do well yet is communicating from orbit back to the ground. And the reason why is because the atmosphere gets in the way. Now, it's not that the atmosphere is going to block your signal coming in necessarily, although it could if you're, for example, working in an optical wavelength and you hit a cloud. It's because the atmosphere can bend the light. And with heat waves coming up from the surface, weather can actually make it miss the target. And so there's a lot of how exactly do we do this? Now, one of the reasons why I'm so interested in this story and it caught my eye was thinking through for years, we've talked about wanting a communication relay from Mars back to the Earth so that we can send more and more missions and not worry about how do they send a signal directly to the Earth. Could this technology work for that? And one of the problems there is how do you send a laser signal coherently a really, really long ways and still have it have enough energy density that you can detect it really easily when it gets to where it's going.
Hence the satellite launch.
Hence the satellite launch. They're trying to work through some of this. And they've got a really good idea of how to make this work. But this is all right, let's actually do it and collect the data we need to make the next generation even better and work generally towards that. And it's just it is another big step in terms of how do we move space from something that's purely research driven to something that's a lot more commercialized in terms of what you can do.
So what's going to happen with the satellite?
It's going to be up for the prime mission is about 2 years long, and it's going to talk back to the Earth. And honestly, I don't know a lot more details than that.
Let's see.
Was that the STP-3 satellite that just launched?
It's the STP Sat-6.
Okay, yeah, that just launched a few days ago, I think.
Yeah, so one of the things is that we know that Starlink is moving into this realm with using lasers to communicate between the actual satellites. So right now, the Starlinks, they communicate with the ground station most of the time, but the long-term plan is for the Starlinks to actually communicate with each other by laser. And if they can pull that off, then what you'll get is actually, because communication through the vacuum of space, light moves much faster through the vacuum of space than it does through fiber optic cables, that actually the fastest way to communicate to Earth from 2 points on Earth is to go out into space and then go around from point to point to point out in space and then come back down through the atmosphere, wherever your destination is. And so there's a lot of work going into figuring that out for communication satellite arrays. But to take that up to the next level and actually be able to have these communications go interplanetary would be kind of phenomenal. Because, like, you've got the inverse square is the inverse cube. It's the inverse cube, right? For sending radio emissions out in space. And so New Horizons,
inverse
for example,
square, actually.
it's the inverse square. Okay, yeah. So like New Horizons can only send data back at a couple of bits per second, while
because it's so far away.
Distances. Yeah. And so if you could send a coherent beam directly at Earth with your data, you could speed things up significantly.
Yeah, because the power loss over distance is much, much lower as well. I mean, it's truly phenomenal that we can actually still pick up signals from the Voyager spacecraft being so far away. I mean, if we collected the entire energy density by the time we got to Earth, it would take months and months to turn on the light bulb. I mean, it's...
Yeah. It's a
just satellite communication is also a really interesting problem with laser pointing, because unlike radio, where it's being broadcast literally in every single direction, and it's easy to pick up, with light, you need to actually focus that back into a detector. And so it's not just can I shoot from target A and hit target B? It's, can target B actually receive that signal when it gets there from that angle? And that's a really interesting thing that NASA's worked through as well with that.
Yeah, interesting stuff. Awesome, thanks, Nick. All right, Beth, let's talk about tracking an asteroid with Unistellar. Not a sponsor of the show.
Not a sponsor of the show, but they could be. Sorry,
we've talked about them twice already. Yeah,
I know. Yeah. So the Unistellar Network, of course, is the citizen science side of Unistellar's project. And what it does is basically allows users of Unistellar telescopes, the EV scopes, to participate in citizen science, which is really cool. And, disclaimer, SETI Institute is the citizen science partner of that. So I do hear about these. In fact, we got the news of this on Daily Space yesterday during an interview with Frank Marchese. And what happened was they basically sent out a call on November 8th saying, hey, there's this near Earth asteroid. We'd like to observe it to get more information about it. But it's going to be passing by in basically less than 24 hours. Who can get out and take a look and actually gather the data? And they got 3 people to spend some time out with their telescopes. And basically, I think their exposure times were only about like 4 seconds, but they got the data that they needed. And so these people actually sent their data back in, and it's being analyzed to sort of, narrow down the orbit, the size, all of that kind of thing.
That's really cool. What is the value of doing this kind of tracking work? What does this help us with?
It really helps us narrow down the characteristics of the orbit, particularly with near Earth objects. That's always really important. This is an orbit that the asteroid is 2019 XS. It's only about the size of a school bus. It's not huge. However, the orbit does cross with Earth. So it's always, of course, a concern. Orbital mechanics being what they are, you want as precise a value as you can get. So all of the observations will help, and being able to observe these things from ground-based telescopes is really helpful. So that's basically what they're doing. they just want to narrow down what the orbit is, get it more precisely calculated, and see if they can learn anything about, say, the mass, maybe even density of this object, and all the pieces are useful for tracking it later.
I guess we'll pass this question to Saverio, who's listening right now. What can you do with this kind of data of like really accurate tracking of asteroids, even by amateur astronomers?
Yeah, that's as like Beth mentioned, like mostly it's the orbit is very 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 important to characterize. If you follow like the asteroid long enough, you can get like how the light is reflecting. You can get something about its magnitude, and so you can make assumptions about like the diameter. But actually, diameter is it's known as the size of a school bus. And then you can start getting maybe even information about the period, like how it rotates and so forth. But that requires like more observations.
What kind of, with this close of a pass with the Earth, it's coming, I think, within like 1.5 times the distance to the moon. Does that have a significant impact on its orbit? And will that shift it potentially into a more dangerous or less dangerous orbit in the future?
It's hard to say without doing specific models. One thing that it's interesting though is that like usually you have a return-facing processes due to the close interaction of the gravity of the bodies. So definitely it get affected in some way. I will not be able to say like how the orbit is affected without modeling it.
But each time we get a fairly close flyby of the Earth's gravity well, it changes the asteroid's orbit.
Yes, I mean, in some way, yes. Like now, if I don't think like it will need to be modeled to understand of how much and on which path. Yeah.
And we have so there's a piece of software they've been using to model near Earth objects, which is called Sentry, and just last week announced that they've released Sentry 2. So it's updated to take some of those sort of gravity well interactions into account now. So hopefully we'll be getting some better orbital calculations as we go, and so this will help that as well. So all that data gets put in the database and used to make those calculations. I remember Apophis passed through a keyhole, and that was a really big deal as to exactly how that would adjust Apophis's orbit and whether it would adjust it in our favor or not.
Yeah, I think and I think at this point it seems like we're okay. Like the 1 in 10,000 chance of it being dangerous at this point.
It's remote. It's like no threat for at least 100 years.
Yeah, so, that's right.
And then even at 100 years, like the threat is really small. So
yeah, that's right. That it was of no threat for at least a couple 100 years at this point. Very cool. All right, thanks, Beth. All right, Dave. Yes. Let's talk about the end of the International Space Station. Wah wah.
Yeah. There's been a lot of news actually out of the International Space Station lately. The NASA Office of the Inspector General released they tweeted it too. I thought it was interesting how they dropped it on us. They tweeted out an extensive report looking at some of the problems they're having with the International Space Station. And the idea right now, the space station is good till 2024. That their recommendation is deorbiting the space station probably by about 2030. And just a few days after that, that's not even a decade from now. Yeah. It was very enlightening, some of the stuff that I hadn't heard, that there's been doing some inspections on the interior of there's several cracks, I guess, on the inside of the station, which is not a good thing, you would think. That there's been a lot of different the station's getting older, it's aging. And it's just interesting that to read through the report, they actually give you a preview of what it's going to look like when they deorbit it. I was surprised how expensive it was. They were saying it's going to be about $1 billion US to deorbit. Wow. You would think you hit a button and just the retro rockets send it into the ocean. Of course, they're going to deorbit it like Mir. They're going to put it over the South Pacific because it's so big that it's going to easily be the biggest thing that's ever come back in re-entry. So a lot of it's going to survive.
Yeah,
when
so
it burns up.
the problem with the space station is that it's so big that it requires an enormous thrust to get it to deorbit quickly enough that you can guarantee that it's going to go down into the Pacific graveyard.
Yeah, they said
And
this it's going to take several years. Like they're going to slowly lower it over time.
yeah, and they've got to change its orientation so that it's face on in the wind. They've got to have both its thrusters fire as well as probably some custom built engine that's capable of giving it a really high delta V to get it slowed down in time. And
there's a point beyond which the crew, of course, is going to have to be off the station.
So, oh yeah, of course. This is after the crew is off the station for sure. But
the report said several years, but I thought it was interesting. They said that if there was any kind of mishap, say that they had to abandon the station. I mean, I don't know if you guys talked about the Russian ASAT missile test a few weeks ago, but that was another problem that they've been having, that there's more space debris flying around now up there in low Earth orbit. Last week, they had to delay a spacewalk because there was a very close debris pass that they eventually, it was a routine maintenance spacewalk to do an antenna change. But this is all happening in a very new environment than when the space station was put up there 20 years ago. So they said if they had to do it quicker, like say if we woke up tomorrow and found out that the crew, whenever they have these debris passes, they're sitting in the Dragon capsule and the Soyuz capsules, ready to just to leave the station and evacuate if they have to. They said it would take about 6 months. Maybe they could do it remotely, bring the station down in a sped up timeline over 6 months.
Right.
If they had to do it.
But tomorrow. It would be tricky, and it would be a very dangerous operation, and they couldn't guarantee that all of the parts would hit exactly where they want them to. It's such a massive construction. It's hard to wrap your mind around.
After that Russian anti-satellite missile test a few weeks ago, they were sitting in the Dragon and Soyuz capsules, the crews respectively, ready to do that. Yeah. We woke up that morning all hearing the news that, Russia shot down their defunct satellites and the crew nearly had to evacuate the station.
Yeah. Their own crew.
Yeah. And about last week, they also, NASA kind of unveiled this idea of transitioning to commercial space stations. There was 3 companies, NanoRacks, Lockheed Martin, and Blue Origin, I know, got one of the contracts that they're looking at steadying the idea of putting up. The problem they're having is, of course, the space station, they're studying human physiology for long-term space flight. This is all leading up to the Artemis missions to the moon, going to Mars in 2030. And the thing is, they're saying that these studies probably won't be done by 2030 on the International Space Station in this time frame. So they want to transition a lot of these over to commercial stations that will be smaller and continue doing these long-term human spaceflight studies.
And I know another country that's got a space station. If this doesn't work out,
yeah, China just put one up there. They're building theirs. The slide they got up there now. There's also Axiom Space. They have an interesting hybrid idea of starting to stack modules onto the International Space Station that eventually could be detached for their own smaller station. So they're going to start doing flights up with SpaceX next year. And I believe by 2024, they want to put their first extra module onto the International Space Station. But
do you think that we'll get to a place where the commercial offerings are good enough and safe enough and reliable enough to smoothly overlap what's happening with the International Space Station, with the loss of the space station?
Ideally, like I said, if this is done over a slow time frame, like they're envisioning in the IG report, if it's done, like I said, if something happens and they have to evacuate the station, and then it would be sad if we had to, because we've had an uninterrupted presence in space. Humans have been in space now since October 2000, I believe. Expedition 1 went to the ISS. So it depends if we have to do it in a hurry, or if we get to do it in this slow incremental time frame like they want to do it.
It's funny, and we're going to talk about this with Nick in a second here, but it's funny how, like, when I posted information about this story, you get heat from 2 directions. That on the one hand, people are outraged that NASA's throwing in the towel of building space stations and kowtowing to big business who's going to build space stations. And And then on the other hand, you've got people who are enraged that this boondoggle even exists, and why don't we have a base on the moon, etc.
Well, I wonder if they just wanted to give Blue Origin something to do after they lost the lunar lander contract. So
poor Blue Origin.
It's like here you go. It's like keep them busy so they're not.
Make us a space station. They're easy. Work on that. All right, thanks, Dave. All right, well, we've got a few minutes left, and we'll fill this time with a spirited discussion about space tourism. Nick, tell us what you got.
Yeah. So there are a couple headlines that caught my eye on this. One of the big ones is that a Japanese billionaire just got flown to the space station along with a staff member. So latest Soyuz flight had 1 cosmonaut and 2 tourists. And this has sparked a bit of debate around some of the people that I know that I like to argue about these things with, of is this a good thing or is this a terrible thing? And this is where there's an interesting culture clash to ask the question of, is space just intended as a research platform for experts who have trained for years to do it? Or is space going to be something that's really becomes truly commercialized to the point where we could send our crew, that is the 5 of us here talking on this show,
we can do the show from space.
And enjoy talking from orbit. You know, you want to talk space telescopes? Look at that one out the window. I mean,
so
what are we trying to do here with space is really the question I want to dig into a little bit. And it's interesting to look back at the history of aviation if you want to compare with this. Early on, there's the Wright Brothers flight, and then what? So if you were just looking for going from then till now without knowing all the little steps in history, it'd be pretty jarring to say, well, these 2 eggheads just put together a aircraft. They flew it for, what was it, 100 feet? Less than that? How are we going to go from there to where we can send people long distances on this flying contraption? I mean, that just sounds like a great way for everything to go wrong. But what happened shortly after the Wright brothers flew is you start to get other people that were enthusiastic about what they were doing and saying, hey, we can fly too, and started building other models of airplanes and started doing stunt shows, performances, where you'd bring the plane to a site, you'd assemble it, by the way, bring it there by train probably, assemble it on the site, fly it as part of a demonstration, sometimes crash, sometimes not. But, you know, people would come out to see this remarkable, strange, odd thing that happened. And that was really the kind of thing that started off as the purview of the wealthy, people that had the kind of disposable income that could buy a kit, put it together, and then risk their own lives flying around on it. Is this kind of the place that we're getting to with space, where we've got billionaires who are founding space agencies and launching themselves and their friends and other notables into space for fun, for profit? And is this an important stepping stone along the way towards, hey, when can I go too? I mean, this Soyuz flight, the price of it wasn't disclosed, but Roscosmos, that's the Russian space agency, has typically sold a seat on Soyuz at around $90 million.
Yeah.
That's selling to NASA. So there's some training and some other logistics that goes along with that. But that's a price I will never be able to afford, particularly as an academic. Will we get to a point where we can launch people?
Yeah. And I mean, I think we probably won't see that revolution until if Starship actually works as intended, but it could very well be that the cost is going to come down significantly down to you could mortgage your house and spend a week in orbit as opposed to.
So that's actually another one of the interesting tie-ins with this news article that caught my eye. The space tourist, I'm going to butcher his name if I try to say it, so I'm just not going to. His first really big announcement of, I want to do this thing, was actually saying, I want to fly on spaceship to the moon whenever that becomes a commercial opportunity. This was the, well, okay, it's been 3 years. I want a taste of space. Fly me to the ISS.
Yeah.
Boy, I wish I had that disposable income.
But then you would be you would be the target of a stern controversy.
Indeed, I would.
Should Dr. Nick Castle, planetary scientist, be allowed to fly to the International Space Station?
I think that's a reasonable question, is when we start sending people more routinely, is this a good thing? I'd say it is, because
you're asking the question. So do you think it's a good thing or a bad thing?
I think it's a good thing, because when you look at more and more international governments national governments, I should say, are not willing to put huge piles of money into spaceflight. If you get a private citizen that says, I will fund the spaceflight, in exchange, you will fly me, or even you will fly me and a staff member, but I'm paying for the whole thing, and we still get some science, we still get some productive use of that spaceflight, great. I mean, I'll ride that train as long as it's on.
Yeah, anyone who's,
for me as a scientist,
who's written a proposal to get funding knows how little funding there is out there.
Yeah.
But I guess, I mean, I think for a lot of people, we're at this transition, and assuming that the cost of space will come down, it does feel like it will eventually become inevitable. And so the question is just, do you want this inevitable situation today, or do you want it in 10 years? But it's going to happen that if the prices do come down, there will be private entities that are having private places in space, and private people will be flying up to those places. And can we force them to do some science? I think is the question that we really want to ask. How do we get them to do some science to help us out?
That's an interesting way of looking at it, of can we keep compelling people to participate in the science when it's no longer primarily a scientific endeavor?
But I think you have a similar situation. Like when you look back to the early explorers, they were in many cases were rich philanthropists, rich people who had a wanderlust, but they would cloak their desire to see the world in doing something beneficial for humanity as well. So they would discover creatures, they would collect samples, they would trade and interact with indigenous communities and so on. And I think that it's sort of that same thing will probably start out where people, I know that even like Richard Garriott and others, when they flew to the space station, did do some science. And I'm sure the the Japanese crew is going to do some science as well. And that'll go for a while, and then eventually there'll just be so many people. You can't force them all to do a science.
But hopefully there'd be enough people that you don't have to force them all to do science. Hopefully that's the science gets done and you didn't need everyone involved to do that anymore. That's kind of the dream. I mean, I have a hard time with the argument of space tourism is inevitable, because I've been hearing space tourism is inevitable and will be a thing my entire life.
Yes.
And I don't just mean my adult life. I mean, since I was a little kid running around. It took major private investments to really start to work on bringing the price of launches down and start to make this, instead of a wish and a promise, into something that kind of feels like it may actually happen now.
Yeah.
So it's interesting to watch. And frankly, wherever the funding comes from, we're moving a step closer to that vision of maybe we can all take part of this. It was actually one of the really cool parts about William Shatner coming back was when he just started trying to talk about that overview effect, that seeing the Earth from a different perspective and having that be something that really deeply emotionally changed him. That's pretty cool.
Yeah, it's I think that was the highlight of the whole process, was his profound view of the Earth from suborbital. And you could see, I mean, every time you talk to astronauts and you bring up this idea of the overview effect and what it feels like, it's amazing, this almost spiritual transformation that they have with their respect to the planet. And the more people we can have experience that, the better. I would love to see it, but I would love some other people to see it as well, who need to have their minds changed. We need to have the appreciation of the planet that we live on changed for the better. So yeah, absolutely interesting, Nick. Thank you. All right, we've reached the end of our hour. Nick, you're still on my screen. Oh, now you're gone. So, but I'm gonna bring you back and give you a chance to let us know what you're working on and where we can find out more.
So the thing I'm working on right now is actually preparing to teach a new course. Well, sorry, the same course again. It's called How to Live on Mars and Not Die. And if you like hearing me talk, if you like talking with people like me, and you like talking about Mars, it's the fun thing to sign up for. You can find it on Eventbrite. Just search for either my name, which is Nicholas Castle, or How to Live on Mars and Not Die.
Fantastic.
You can buy tickets for it. I think it would make a great Christmas present. And it's running in mid-January. It starts January 15th.
Excellent. That sounds great. Dave, what are you working on?
Frequent contributor, Universe Today, Sky and Telescope, and I'm doing the end of the year post for each one respectively on what's going on for astronomy for next year in the sky for 2022 and what's going on for space launches. And it's amazing when I started turning my attention to it, it's like, there's a lot of moon missions next year. If even half of them go, it's going to be a really busy year because we're going to turn the calendar and SLS is getting ready to launch for their Artemis 1. That's going to be a big deal. Finally, SLS is launching.
So wait, so we get one and Sky and Telescope gets one? Is that how that's going to work?
I usually do. I cover the space flight beat over at Sky and Tel more, so I'm doing the roundup for every year. I do all the missions, and usually I've done for several years now for Universe Today. I know we have 2 big total lunar eclipses next year. Mars at opposition again. That's always big, and maybe we'll have that big comet of the century finally next year.
Finally, yeah. This is it. This is our year.
Never know.
We'll just keep waiting for it. All right, Beth.
I am continuing to work on Daily Space, and also my articles are appearing on Medium at planetarypan.medium.com and over at SETI Institute. Some of them end up over there at SETI.org. And next week and the following week, I will be the host of the SETI Live events. So we'll be talking about DART, and we will be talking about sort of our end of the year wrap up as well.
Fantastic. All right. And Saverio, you've stuck around, so you get another chance to let us know what you're working on. Again, if people want to find this paper and learn more about Bennu, where should they go?
Sure. So the paper is accessible with a shared link to my website. So you just click on the link next to it, and it should be a PDF basically.
Perfect. And we'll put a link in the show notes as well for this.
Yeah, please.
Wonderful. All right. And of course, I'm Universe Today on all the things. I had a fascinating interview today on my channel, which you may want to come and check out. I got a bunch more interviews coming up for the next couple of days. So lots of really good stuff coming up. It's going to get a little weird over the holidays as we take some breaks. No open space on Monday. So I'm going to be out of town for a couple of days at that point. So I won't be able to do a show on Monday. Maybe reschedule. But anyway, thank you, everyone, for joining us today here on the Weekly Space Hangout. We really appreciate it. Thanks to all of my co-hosts, our special guests. Thanks to all of the moderators in the chat, everyone watching us both on Twitch and on YouTube. We really appreciate it. Special thanks to Nancy Graziano for keeping us all organized, and Dr. Pamela Gay engineering this show from behind the scenes. Thank you, Pamela. All right. For all of my guests, all of our co-hosts, we will see you next week. Thanks, everyone.
Thank you.
Bye.
Thank you. Bye-bye.